Hello students, welcome to my channel MS Maths. So today for task 10 we are going to learn something about complex number which will be represented graphically and also some of the properties of complex numbers. So let us start. That is 2.6. 2.6 which is page number 64. So here some graphical representation of complex numbers. First preliminary idea is here given. So you can understand that because as you know graph, already you got graph uh, representation or plotting some points on a graph paper that already you learned in lower classes or in general maths. Now we will learn how to plot the points of complex numbers on this graph that is called Argand plane. Already I explained you Argand plane. Anyway, this is called Argand plane. This graph, this is a plane which is called Argand plane. Diagrammatic representation of complex number in a plane. So we have already discussed every complex number z equals to x plus iy can be represented by an ordered pair xy which is real. Z equals to x plus iy is a complex number, but x comma y both are real number. X comma y means this is a pair, ordered pair. We already got in first chapter ordered pair. Ordered pair which is xy belongs to R, real numbers. Also we know that if real scales are chosen on two mutually perpendicular axes, x that ox, y this r, which are called x-axis and y-axis respectively, then we can locate any point in the plane determined by these lines by the ordered pair of real numbers xy called rectangular coordinates of the point. This is called rectangular coordinates of point. This one, rectangular coordinate, or we shortly we will say coordinate. Since a complex number x plus iy can be considered as an ordered pair of real numbers, we can represent such numbers by points on xy plane. This is also called xy plane. Thus we have seen that to complex number. So anyway, it become reason. So this plane is also sometimes called an Argand plane. Why this plane is called Argand plane? Because in the honor of Jean Robert Argand, 1768 to 1820, a mathematician of Geneva. Jean Robert Argand was a mathematician who was from Geneva. In 1906 had published an account of the graphical representation of complex number. Graphical representation of complex number was invented by Jean Robert Argand. So this plane is called Argand plane according to his name. His surname is Argand, Jean Robert Argand. That is why it is called Argand plane. And this one also we can say simply a complex plane. In a graph in which we can represent complex number, we can plot, we can locate complex numbers, that plane is called Argand plane. Now here suppose this is suppose y-axis, this is x-axis. This part at least you know what is x-axis, what is y-axis, that part at least you know. This is called origin. That you know. So there is no problem to draw x-axis and y-axis. So here, for any complex number, first of all we have to make an ordered pair. And of course we know this, whatever numbers are there in the inside the bracket, this will be for x, and the second one is always for y. That we know already we got in linear equation. First, in the pair, inside the pair, whatever number we write, first will be always for x and second is always for y. So this one also x plus iy. So for 3x, for y 4, is I only. So that means what do we understand? That imaginary number, this is imaginary number. Imaginary number will be represented. Imaginary number will be located with respect to y-axis, not x-axis. X-axis is for real numbers. So that is why x-axis is called real axis, and y-axis is called imaginary axis. So this pair, from the complex number, whenever we get an ordered pair, so that can be plotted, that we know already. Graphical representation of any point we know, because this first quadrant is for plus plus, that is minus plus, this is minus minus, this is plus minus. That we know already. That we already know. This quadrant is for all positive numbers. This quadrant is for x negative, y positive. This quadrant is third quadrant, in which x and y both are negative, and this is fourth quadrant, in which x will be positive and y is negative. So that's all. That already you know. So just I have repeated, reminded. So this is called Argand plane. Now, okay, let me show you some plotting of points on the graph paper for some complex number. -4 plus 3, I suppose. Then what will be the ordered pair? 4 minus 4 comma 3. -4 comma 3. So those who have forgotten to plot the points, how to plot the points, please learn now also. -4 is for x and 3 is for y. So -4. So this side 4x minus, this side 4x all plus. You can remember that way. Upper side y will be positive always, and downside y will be always negative. So whenever we get x negative, we will have to count the left hand side. So x there is -4. So 1, 2, 3, 4. This is -4. Then y is 3. Y is positive. So we will count up. 1, 2, 3. So this is the number. Just this is the plot. -4, 3. This is the point. So this way you can plot any points from complex number. You don't have to worry that how can we plot the points of complex numbers. That is nothing. Two numbers will be there. Just you have to plot the points, plot the numbers. That we already know. So that there is, I don't think there will be any issues. Now 2.6.1 remark. Some students may find, okay, anyway, I will make it short. Let us consider two real scales on the mutually perpendicular lines x dash o x and y. That means what? This is y-axis. It is visible or not? If it is not visible, then we will take yes, this will be visible. So this is y-axis, and suppose this is x-axis. So what we write always y o y dash. This is y dash. Sorry, O, origin. This is called origin. O means origin, that you got already. So those who have forgotten, please learn now also. This is called x-axis, this is called y-axis. And this is also called a real axis. This is called imaginary axis. And upper side all y positive, downside y negative, left side of origin all x negative, right hand side of origin all x will be positive. So that is what you have to remember. Now this is the figure, it is shown here. 2 in positive part. Okay, A2 is located on 2 on positive part of x dash O x axis, and B2 is located on minus 2 on negative part of 2 and minus 2. So 1, 2, this is 2 and this is minus 2. This is 2 and this is minus 2. This is 2, so this is taken as A2 and other one is taken as B2. This is minus 2. This side counted 2 plus 2, this side counted minus 2. Now we know that is located minus 2 on negative part of, we know that minus 2 equals to minus 2 into minus 1 or 2 into I. As we know, sorry, I square. I square is minus 1. That we know already. Already we have learned I square is minus 1. So what can be written this one also? 2 into I into I. 2 into I into I. So 2 into I into I. So it is seen that when 2 is multiplied by I twice, then we get minus 2. That means what? From here to here, if we move, we have to multiply I twice. First A2 is 2. A2 is 2. A2 is 2 and B2 is minus 2. That means which 2 if we multiply I 2 times, then we get minus 2, as we have seen here. 2 into I square is minus 1. Minus 1 into 2 is minus 2. So that is what here written. So it is seen that when 2 is multiplied by I twice, then we get minus 2. We can assume that when 2 is multiplied by minus 1, that is twice I twice, then location of the 2 is turned through an angle of 180 degree anti-clockwise. Anti-clockwise. So from here it is moved to this. First starting is here, then moved here to here also too. Remember that. So here to here moved, then here it is moved. That means here to here, 2 I twice. 2 into I is minus 2. With 2, if we multiply by I 2 times, then we get minus 2. It means what? Here to here I, here to here I. 2 times I multiplied, that is minus 2. That is what written here. That means what? Here, this is straight line. This is a point. So like this, if it moves anti-clockwise or clockwise, no problem. This is always 180 degree straight line. This is 180 degree. That means I square is equal to 180 degree. I square means 2 times I. 2 times I movement means 180 degree. That means 1 round, half round. Total if there is round, that is circle, that is 360 degree. So here to here half round, that is 180 degree. And we get the position -2. So multiplication by I once the point 2 is shifted to 2i on OY. So what is this? 2 into I, 2i. This point is 2i because I means 90 degree. One more I, 90 degree. That means I means 90 degree. So here to here it is 90 degree perpendicular. 90 degree. So this is 2, this is 2i, this is -2. That is what written. So multiplication by I once the point 2 is shifted to 2i on OY axis through the rotation of angle 90 degree. If 2i is multiplied by I, then it is -2, which is on OX dash. So look here, this is 2, this is 2i. With this 2i, if we multiply by I, that means here to here I only, here to here I, here to here I. 90 degree means I. So with this 2i, if we multiply I, this will become 2i square. 2i square is -1, -2. I square is -1 into 2, -2. So here it comes. So for 180 degree, we have to multiply I twice, I square. For 90 degree, we have to multiply only one time I, once I. That is what you have to remember. So now look here. From here, if it is from this point to this point, if there is movement, this point means how much? -2. Here to here 90 degree, that means we will multiply by I. So this will become -2i. So which will become -2i? This will become -2i. So here to here movement is done. Because here to here I, here to here I, here to here I. So I movement is done. So from here to here again move. That means with -2i, we will multiply I. So -2i square. -2i square is -1. So +2. So it is +2. So with 2 multiplying I, we get 2i. If 2i we multiply with I, we get -2. With -2, if we get multiply by I, we get -2i. So what we have seen now? On x-axis, we are not getting I. This is 2, this is 2, this is -2. But on y-axis, we have seen this is I, this point there is I, this point also there is I. It shows that y-axis is imaginary axis, x-axis is real axis. But we have proved here, we have seen that there is no I on x-axis. That is what we have shown here. Why x-axis is called a real axis, why y-axis is called imaginary axis. So here to here, 190 degree means I. Remember that 90 degree means I. I time movement means 90 degree movement. So I hope you understand this. So this way you can go on processing. So here 2, again 2i, this way you can go on multiplying. Here suppose 1, 2, 3, 4, 5, 6. This is 6. So 1, 2, 3, 4, 5, 6. So this is 6i. This way. Then 1, 2, 3, 4, 5, 6. This is -6. -6. 1, 2, 3, 4, 5, 6. Here there will be I because y-axis. Again this way. This is a circle. My diagram is not so good, but at least you understand, I think. So here this is 6i. This is -6i. Above positive, below negative. Why? So above +6i, down -6i. Counting is same. 1, 2. This is O, means 0. 1, 2, 3, 4, 5, 6, -6. 1, 2, 3, 4, 5, 6, +6. So here I is there, here I is there, y axis. Here minus 6, here 6, no I. So this is real axis. X axis is called real axis, that is y, and y axis is called imaginary axis. Okay. Again, we know that Z1 equals to 3 plus 4i. Z1 equals to 3 plus 4i is the point C4 lying on the first quadrant. Z2 equals to minus 3. So third quadrant, it's in that Z3. Okay. Now Z1 is a complex number, that is 3 plus 4i, and Z2 is another complex number, that is minus 3 minus 4i. So for this ordered pair will be 3 comma 4, and for this ordered pair will be minus 3 comma minus 4, minus 3 minus 4. Now it is seen that Z1 is multiplied by I 2 times, then we get the number minus 3 minus 4i. So we will see now 3 plus 4i, 3 plus 4i, if we multiply by I 2 times, what do we get? Do we get Z2? Let us see now. 3 plus 4i into I square. I into I means I square. I square is minus 1. So what we do? Minus 1 if we multiply with 3, minus 3. Minus 1 if we multiply with plus 4, so minus 4i. So which we got Z2. So what do we understand? That 3 plus 4i, if we multiply by I 2 times, then we get minus 3 minus 4i, Z2. So that is what here written. It is seen that if Z1 is multiplied by I 2 times, then we get the number Z2 equals to minus 3 minus 4i. Both the points are lying diagonally opposite to each other. It means the line segment joining these 2 points is divided at the origin. If theta be the angle, so that we will see later on. Let us see now. X dash, X, Y, Y dash. This is origin O. Now we have to plot 3 comma 4 and minus 3 comma minus 4. We will just plot the point. 1 2 3, 1 2 3 4. This is 3 comma 4. That I think you have understood. Another one is minus 3 comma minus 4. So both minus, third quadrant, both minus. This is only the quadrant in which both x and y will be negative. Anyway, x will be always negative towards left side. So minus 3 comma minus 4. 1 2 3, 1 2 3 4. This is minus 3 minus 4. This is the point. This is for Z1. This is for Z2. Now, if we draw a line, when joining these 2 points, if we join the points, then this line segment will surely pass through origin, and both the points will be always opposite quadrant to each other. This is first quadrant, its opposite quadrant is third quadrant. This is second quadrant, its opposite quadrant is called fourth quadrant. So whenever we multiply a complex number with I 2 times, then we get another 2 pairs in opposite quadrant. Both the points are lying diagonally opposite to each other. Opposite to each other. It means the line segment joining these 2 points is divided at the origin. If so, this line segment is dividing whole plane into two parts, totally equally two parts. That is different thing, but this line segment will pass through origin. Remember that. Now, if theta be the angle made by the line joining 3.4 with x-axis, then minus 3. Okay. Now this is the angle, suppose theta. This line segment making an angle of theta with x-axis. This is x-axis, this angle is theta. So here to here how much? This is here to here. Look what I am drawing. Here to here. Here to here. How much? It should be pi. Pi means what? 180 degree. That we got already. Here to here, it will be pi. Why it is pi? This is a straight line. Straight line. This is a point. How much this one? This one is always 180 degree. Or pi, same thing. Pi will be in radian, 180 degree in degree. So anyway, pi means 180 degree. So here to here it is pi. I think you have understood. This is a straight line. Here there is a point. So this angle will be always 180 degree. Or pi. Or pi. So from here to here it will be pi plus theta. Suppose this theta is 30 degree. Suppose I am saying this angle is 30 degree. Here to here 180 degree. So from this place to this place, what will be the measure of angle? 180 degree plus 30, that is 210 degree. 210 degree. So pi plus theta with x-axis. Then the line joining origin and minus 3 minus 4 will form an angle pi plus theta with OX. This is OX. Here to here it is OX. Here to here the angle is pi plus theta. With OX, total angle is made by this line segment is pi plus theta. Because you have to start from here and ending at here. So here to here pi. I hope you understand. So that is what here it is shown. This is the diagram in the page number 66. Page number 66 it is shown. Please repeat, watch the video, what I have told, what I have explained, you can repeatedly, you can go on hearing. You can listen what I have taught. Okay. Number 2.7, modulus of complex number and its properties. Modulus of complex number. Okay. Let us take complex number z equals to x. Z equals to x plus iy. This is a complex number taken left. As discussed earlier, this number can be considered as pz or pxy. So that means order pair will be x comma y. That is taken p. The name of the point is p. Okay, let us draw x-axis, then y-axis. This is O, and pxy on organ plane. Okay, p is just a point taken anywhere. Here suppose this is p, coordinate of this point is xy. It means what? Here to here x, here to here y. We count x here and count y this side. Counting x this side, y upward. So that is why this is the point. 3, 4, like that. Any point P is taken, the coordinate of that point P is x, comma y. X, comma y. I hope you understand. Okay, this is the point P. Here the coordinate point is xy. So from PM is perpendicular drawn on OX and OP is joined. From P, one perpendicular is drawn on OX. This is perpendicular. This is PM. After that, OP is joined. So this has become a right angle triangle. So now we have to find out OP. This is a right angle triangle. Right angle triangle PMO. So since this is a right angle triangle, this is hypotenuse. We know that hypotenuse square is equal to base square plus perpendicular square. Here what can be written? OP square is equal to OM square and PM square. This is Pythagoras theorem. I hope you have this one is in your brain. I hope that you know this one. Pythagoras theorem is related to always right angle triangle in which hypotenuse square is always equal to base square plus perpendicular square, or in another word we can say hypotenuse square or longest line square is equal to the sum of other two sides square. That way also you can say, no problem for that. Now look here, OP square equals to OM. How much is OM now? How much is PM? That is what our question now. Because we have to write something here. Then only you can go for the other every time we cannot write OM square PM square. No. Instead of in place of OM we have to write something. So what will we write now? So here to here, how much is the count? Look here. If this is the point, how can we count? 1, 2, 3, 4. So we will write minus 4 first because this side counting. 1, 2, 3, 4. So this side and so forth. Like this we count, no? That means here to here 4. So that is where first number comes. First number is counting of x-axis. Here first number is counting of x-axis. So that means what? OM is x square plus PM. Here 4 second number is counting of y-axis. These are all are y-axis and these all are x-axis. So here this count is in how much? Here y is written. That means counting is y. I will show you here shortly again. This is O. This is x-axis. This is y-axis. So this one I have written like this. So what I will write here? 1, 2, 3. So 3 I will write. Then 1, 2, 3. 3 we will write this way. So let us see. Let us see this one. This one. What is this? We have to count first x-axis. From origin we will count 1, 2, 3, 4. So let us write 4. Then 1, 2. 2, that means first number is counting of x-axis. Second number is counting of y-axis. So first number is counting of x-axis. Second number is counting of y-axis. So how much is written here? X, y, y. So like this 4, 2, x, y. So OP is equal to, square was there. So it will become x square plus y square. This distance of the point P from the origin is called modulus. What is this? For the right angle, this is hypotenuse. But any order pair, this point and this is origin. This is origin. O. From O to point, whatever the distance, that distance is called modulus. OP means distance of the point from the origin. OP. P is the point, O is the origin. So O to P, there is a distance, there is a line segment, and OP is equal to square root of x square plus y square, which is called modulus. Modulus of the complex number. So this is a formula. Modulus of the complex number. So any complex number, Any complex number, first one is x, second one is y. Z equals to 4 plus 3i. So this is x, this is y. So if we want to find out modulus, then square root x square means 4 square, y 3 square. So whatever calculation comes, we will do that. That is called modulus. Modulus means the distance between the origin and the point. The point means what? In which a coordinate will be there. In coordinate means what? First number is for x, second number is for y. Because in complex number we always get x and y. Maybe 0, maybe 1, that doesn't matter. But x plus I, y. First is for x, 4 plus 3i. First is for x, 3 is for y. So any point, 4, 3, 3, 4. So both are positive, so we have taken in first quadrant. If it is negative, then we could have taken in different quadrant. Anyway, from origin to the point, whatever distance, that distance is called modulus. Remember this and formalize this. So if a complex number is given 7 plus 5i. So let me write one minus, then you will understand. 3 minus 4i. So modulus, directly go for a square root x square plus b square. Oh, sorry, y square. This is x, this is y. Modulus formula is plus. In the modulus formula, there is always plus. There is minus, or this one minus, this one plus, minus, any mix. So you will write always plus. This is the formula for modulus. This is the formula for modulus. This one is formula of modulus. What is modulus? Let me repeat. Modulus means distance between origin to the point. Which point? Order pair. This is order pair. This is the point. Order pair means coordinates. Coordinates you will get elaborately. Coordinates you will get in explain mode in different chapters. This is there in book. So now let us go to find out the modulus. So what we have understood, that to find out modulus, there must be a condition. What condition? The condition is that a plus ib form or x plus iy form. The complex number must be in x plus iy form. Then only we can write x square plus y square. If it is so many numbers given y 2 times 3 times x, so many numbers, so we cannot do anything. So anyway, in complex number, whatever you do, we have to make the complex number in a plus ib form. Then only we can do something. Otherwise, we cannot do anything. So here, find the modulus of the following numbers. Number one, z equals to 2 minus 7i. So this is x, this is y. So modulus. So I forgot to say modulus sign. Modulus sign is this one. We shortly say mod. This is the sign of modulus. Here, if z equals to 4 plus 3i, if we want to find out modulus of z, then we write this way, z mod. Shortly we say mod. We don't say every time modulus. Mod of z is equal to 4 square plus 3 square. This is the symbol of modulus. 2 lines. Just that is the symbol. So here z equals to 2 minus 7y. So modulus of z, mod of z, directly square root 2 square plus 7 square. So 2 square is 4, 7 square is 49. So that is 53. This is 53. Finish. This is modulus. Only to do the squaring of both x and y, that much. There is nothing. So number 2 we cannot do directly for modulus. As we did many sums in previous exercise, everywhere we have done first a plus ib form. After that only we have done whatever is required in the question. So this number 2, z equals to this is given. So this is first converted to modulus, a plus ib form. This conversion you know already, that already I taught you. So here it is got 1 minus 2i. After doing calculation of this number 2, it is got z equals to 1 minus 2i. So modulus of z, square root directly, 1 square plus 2 square. So that is calculation. Root 5. This is root 5. You can check it yourself. So this part already you did. So this one I am not going to do again and again. This calculation is done by you, and I have already taught. I have already explained in previous exercise. Now properties. These properties are very, very important. This property you have to learn. Properties you have to remember. Properties number A. The modulus of the conjugate of complex number is equal to the modulus of the complex number. That is, Z is a complex number. So shortly let me say, mod of Z equals to mod of Z bar. Let me read this way. You also read this way. No need to read so many things. That means, it means that mod of or modulus of any complex number is equal to modulus of each conjugate complex. If a plus ib, a minus ib. That's what I am saying. How? Let us see an example. First, directly, z is equal to suppose x plus iy. So z bar is x minus iy. That we know already. Already we have got. Z is x plus iy, z bar is x minus iy. Only imaginary part sign will get changed. Now left hand side, what is there? Z. Z means x plus iy. Mod of x plus iy, directly x square plus y square. Let us do now right hand side. Modulus of z bar. Modulus of z bar. Z bar how much? X minus iy. X minus iy or x plus iy. So modulus will be always plus, that I have already told you. So both are same. That is why it is proved. Property number A. Modulus of conjugate complex number is equal to the modulus of complex number. Same complex number. So what do we understand? Suppose 3 plus 4i. So each conjugate will be 3 minus 4i. So 3 plus 4i, 3 plus 4i, this way. Mod of 3 plus 4i is equal to mod of 3 plus 4i bar. Or you can say conjugate of 3 plus 4i. So that is same. Already we have done. How? Root 3 square plus 4 square. Here also if it is 3 minus 4i, modulus, bar 3 plus 4i means it will be 3 minus 4i. So root will be always plus. Here plus only, no? In the formula there is always plus. So we don't have to worry whether it is conjugate or not conjugate. No problem. That is PA, properties number A. Properties number B. Modulus of complex number is equal to modulus of additive inverse. So, if Z is equal to x plus iy, additive inverse means minus Z, minus x, minus iy, minus x, minus iy, additive inverse. Already we got. If Z is a complex number, its additive inverse will be minus Z. So x plus iy is the complex number. Each additive inverse will be minus x minus iy. So let us see now both are same or not. Both are same or not. Let us see mod of z and mod of minus z. Let us see they are same or not. Modulus of z, what we will write? X plus iy. Modulus of minus z, what we will write? Minus x minus y. This one we will find out what is called modulus. Modulus of x plus iy is what? X square plus y square. Here also modulus of this x square plus y square. Even we write, if we write this way, then also we will get same thing, because minus square is plus. If we write this way, minus x as it is, minus y as it is, then also we will get positive only, because whole square, minus square is always plus. So this one and this one equal. This is what there is written. Mod of z equals to mod of minus z. Modulus of a complex number is equal to the modulus of its additive inverse. This is a property. Just you can do yourself also, just I am explaining only. The product of complex number its conjugate is equal to square of the mode of the number, that is like this. So you don't have to read so many things. Z bar equals to this one. So how to read now? Look, Z into Z bar equals to mode of Z square. That is what, or in another way, one complex number into its conjugate is equal to modulus of the complex number, or sorry, square of the modulus of the complex number. That way also you can read. By looking this, you can read yourself. So this one can be proved. This proof is given, still I will show you. Z is equal to suppose x plus iy. So Z bar will be equal to x minus iy. That we know already. So now left hand side, let us do this. Z x plus iy into Z bar x minus iy. So a plus b into a minus b. A plus ib into a minus ib, already we have got x square plus y square. Those who are new today, you are watching my video, this video. If you did not watch my previous video, then you will not understand this. So before you watch this video, please learn what was taught in previous video. Otherwise, you will never be able to learn. So I am not going to teach you again and again. I am not going to explain again and again. That will be just wasting of time. So these things, a plus ib into a minus ib is a square plus b square. If you are new today, then you will not understand. So kindly go to previous videos. After that only you will go to this video. Then otherwise you will not understand anything. Anyway, a plus ib into a minus ib is a square plus b square. That was taught earlier in previous video. Now let us do this one. Left hand side is done. We have got x square plus y square. Now mode of z square. Z means what? X plus I y. So there is square. Let us write square. Square. Forget about square now. This is mode of x plus I y. What you like? X square plus y square. This square is there already. Mode of x plus iy is square root of x square plus y square. We have done just now. This square I have put as it is. Square and root cancel. That we know. So x square plus y square. Here we have got x square plus y square. Here also x square plus y square. So this one equal. This is property number 3. Property number 3. Property number 4, PD, the modulus of, so I will not read this one. Property number 4, mode of Z1, Z2 is equal to separately mode. So how to read? Mode of Z1 into Z2 is equal to mode of Z1 into mode of Z2. Okay, there are two complex numbers. Modulus of multiplication of both the complex number is equal to modulus of one complex number into modulus of other complex number. That is what how to read. We don't have to read line by line from there. So this can be proved by yourself. So that is very long. It will be very long, or even if it is not long, so you don't have to worry for that. You can go or you can do yourself. Or I can also show you, no problem for that. Z1 and Z2, two complex numbers. Or we can take the help of this property number C to prove this. We know that product of means multiplication of two complex number is always complex number. So Z1 and Z2, if we multiply, we will get another complex number. Surely we will get a complex number. This one, if we two complex number, if we multiply, we will get surely one complex number only. So Z1, Z2 is a complex number. Therefore, applying property C, we get. What do we get? Look here. This one. What was there in property number 3? Z bar. So this one here we have to see this one and this two related to this. So Z1 Z2 square, or this one is Z square. That means what? As I have told, as it is written there, multiplication of two complex number is a complex number. So let us see, this is the complex number. After multiplying Z1 and Z2, suppose we have got Z. That is what I am saying. Again, let me repeat. If we multiply two complex number, we get a new complex number. But we will get surely a complex number. So Z1 and Z2, if we multiply, we get a new complex number. That is Z. So square is there already. Okay, square is there already. So now this one, this part we have got from here. This one. This new complex number we have written this way. Now let us write Z1 Z2 square. Now what we will write here? Z means what? Z1 Z2. So Z1 Z2. Again, Z means what? Bar, let the bar be as it is. Z means what? Z1 Z2. This is what written. Now Z1 Z2 square is equal to Z1 Z2 into this Z1 Z2 bar in number okay. This one, look here. If x plus iy into a plus ib bar, this is together bar. In previous exercise, previous topic, we have got this way. Look here. Z1 Z2 equals to Z1 bar into Z2 bar. This already we got. We have got now modulus only newly, but this one already we know. Together bar we can write separately. Multiplication of Z1 and Z2 bar equals to multiplication of Z1 bar into Z2 bar. This one already we have got. So this one let us write separately now. Now we will multiply this way in such a way that Z1 bar, this one and this one multiplication, Z2 bar. Nothing here, nothing new. This one and this one multiplication, everywhere multiplication, so we can add anywhere. Z1 into Z1 into Z1 bar, Z2 into Z2 bar. Okay. Now Z1 Z2 square. What was the formula? Z into Z bar is mode of Z square. If Z3 into Z3 bar, then Z mode of Z3 square. Okay, let me explain again. Z2 into Z2 bar equals to Z2 square, mode of Z2 square. If Z4 into Z4 bar equals to mode of Z4 square. So Z1 into Z1 bar, mode of Z1 square. Z2 into Z2 bar, mode of Z2 square. I hope you understand this one. So from, look here, x square equals to y square z square. We can write x square equals to yz square. Square you can get cancelled, x equals to y. This is general maths. So same thing here, x square equals to y square into z square. So square you can get cancelled, z1 z2 equals to mode of z1 into mode of z2. Hence proved. This is what we have to prove. So please repeat this one, then you can understand again. Whatever I have explained, please repeat. Please go back to video and play it and check it again. Repeat so you can understand them. Number 5. For two complex numbers, so let me write first. Modulus of Z1 by Z2 equals to modulus of Z1 by modulus of Z2. So how can we read now? If the division of modulus of division of two complex number is equal to division of one modulus of complex number by another modulus of complex number. So this one just to memorize the picture. You cannot read this one. Just memorize the picture. As a whole, modulus is there. So separately, modulus is there. So in previous also, just memorize try to remember a picture. This one, picture. So modulus of two complex number equals to modulus separately. Together, separately. This way you have to learn. There is nothing new. This is not hard. This one you have to remember. This one you have to remember. Just memorize the picture. Catch the picture. What is written? Here also catch the picture. It is easy. Don't worry for the proof, because this will be used in different sums. So it is proved here a different way. So if we can take any example in place of Z1 and Z2, A plus IB, C plus ID, then you can do yourself that prove. You don't have to go this way. If you go this way, then also no problem. And this one we can write Z1 as Z1 equals to this way. How? Look here. Z1 is equal to Z1 by Z2 into Z2. So let me show you one example. X is equal to X by Y into Y. The same thing. X is equal to X by Y into Y. So if we get cancel Y and Y, then X will get. So same thing here it is written. Why it is written like this? Because in the formula Z1, Z2 both are there. So first let's take Z1 equals to Z1, this one, if we get cancelled, this way you can write. Now, let us put modulus both side. Both side just put modulus. Then here modulus of Z1 into Z2 is equal to mod of Z1, mod of Z2. We know already. We have got here. Here we have got. So Z1 into modulus of Z1 into Z2 equals to modulus of Z1, modulus of Z2. So modulus of, that means two complex number. So multiplication of two complex number, if it is together, we can write it separately. So here also 2. So we will write separately. I hope you understand. Think that this is X, this is Y. This is X, this is Y. So X, modulus of XY is equal to modulus of X, modulus of Y. That is what we have done here. Here it is then by property. That is property we have got in previous one, previous number, property number 4. Now, what we will do, look here, this one you may not understand. This X is equal to Y into 4. Then what can be written? X by 4 equals to Y. Same thing. I hope you understand. If we cross multiply 4 into Y, 4Y. So same thing. This one you think as 4. This Z1 as it is, this will go down here. I hope you understand. This one if you have understood, this one you will understand. Equals to mod of Z1 by Z2. So actually what we have to prove? This one. This one. So this side you can make it other side, no problem. So mod of Z1 by Z2 is equal to separately mod. Mod of Z1 by Z2 equals to separately we have got mod. So this is proved. So with the help of the property number 4, we have done this one. So this way also you can learn, and it may come in exam to proof. If it comes in exam to proof, then you have to apply this process. I hope you understand this. It is not so hard. PF. So here Z is a complex number. Z inverse is equal to Z by mod Z square. This is what we have to prove. What we know that means since we know that Z bar equals to Z square. This one we have got already. This one we already got. Z bar is equal to mod of Z square. Property number 3. This one already we have got. Now dividing by Z2. Both sides we will divide by Z2. Why we will divide? You will understand. Z dot Z bar by Z square. Z square by Z square. What we have done? Dividing. Here it is written. Okay. Dividing by mod of Z square. Dividing by mod of Z square. What we want to get? Z inverse. Remember, how do we get Z inverse? To get Z inverse, what we need? We need 1 by Z. If we don't get 1 by Z, then we will not get Z inverse. So we are trying to get here 1 by Z. Look here. Z into Z bar by mod of Z square equals to 1. This one cancel. It's not it. I hope you understand. Now, this one let us write this way. 1 is equal to Z dot Z bar by mod of Z square. Same thing I have written alternative way. So here 1 by Z equals to Z bar by mod of Z square. I hope you understand. I will show you one example. 1 is equal to X into Y. We can write 1 by X equals to Y. This can be taken as. If we do cross multiplication, we will get same thing. This is X, this is Y as this. So this one has gone down. So as I have told you, to get Z inverse, we have to get 1 by Z. Then only we can write Z inverse. In place of 1 by Z, we can write Z inverse. What is to prove? Z inverse equal to Z by mod of Z square. This Z bar is there. This has not come. Z bar is there. Sorry. Z bar is there. Z bar by mod of Z square. This one finished. Next property. The modulus of the sum of, okay, let us write directly. Mod of Z1 plus Z2 is less than equal to mod of Z1 plus mod of Z2. Less than equal to. So means what is proof here? Proof is not required, but you have to understand actually what is written here. Suppose 5 plus 3i and 4 plus 4 minus 3i. This way. So if we do this mode, then here 5 plus mod of 5 plus 3i and mod of 4 minus 3i, this will be always greater or equal, not less. This will be always greater than this or equal, not small. That is what I have told you to understand. So this one proof is not required, so you don't have to think so much. So the sum of two complex, modulus of sum of two complex number is always smaller than equal to the modulus of one complex number plus modulus of other complex. You have to memorize, you have to catch the picture. Please catch the picture. Then only you will understand. Then only you can remember. So this side, what is called bigger. This will be always bigger, this will be always smaller. If it is negative, it will be opposite. Z1 minus Z2. If mod of Z1 minus Z2 will be opposite. It is smaller, it is greater now. This one. Second one, proof is not required. If sum, then smaller. If difference, then greater. You have to catch the picture of the formula. One more there is. So previous one plus plus minus minus. Now it is mixed. If difference of modulus of two complex number is always smaller than equal to the sum of separately modulus of both the numbers separately. This is what proof H and I are not required at this standard. This proof also not required. Proof will not come in exam. You have to memorize the picture. You have to catch the picture of the formula. Now J, for two complex number Z1 and Z2, this will be required. This is important also. This J is important. This property is very important. What is written? Z1 plus Z2 modulus of Z1 plus Z2 whole square plus modulus of Z1 minus Z2 whole square is equal to 2 modulus of Z1 square plus modulus of Z2 square. So this one is a formula, very important. Modulus of Z1 plus Z2 whole square plus modulus of Z1 minus Z2 whole square is equal to twice modulus of Z1 square plus modulus of Z2 square. This is what you have to prove. Now here we have to take some what is called complex number for different Z1 and Z2. Taken x plus x1 plus I1 and Z2 taken x2 plus y2. So after that we will go on doing. Let us take, I will show you Z1 is equal to, let's take an x1 plus I y1. So you don't have to worry about this one. Z2 is equal, just for convenient, just it is taken like this so that you can understand, you can differentiate the numbers. So here Z1 plus Z2 is there, Z1 minus Z2 is there. So Z1 plus Z2 we will do, and we will also do Z1 minus Z2. Z1 plus Z2, x1 plus I y1, x2 plus I y2. So what can be written? x1 plus x1 plus, let us write clearly. Z1 means what? x1 plus I y1 plus Z2 means what? x2 plus I y2. Now we will write what is called real part and imaginary part together separately. x1 plus x2 real part, I y1 I y2. So I can be taken common, y1 plus y2. I hope you understand. We have taken real part and imaginary part separately as we do always, a plus ib form. Now Z1 minus Z2, Z1 minus Z2 also we will find out. Here Z1 plus Z2 is there, so we have done. Z1 minus Z2 is there, we are going to do x1 plus I y1 minus Z2. Minus is there, so I am putting bracket here, x2 plus I y2. Let us break the bracket now. x2 minus I y2. So we will write real part together. I will be taken common, y1 minus y2. Minus is there. So we have got the value of Z1 plus Z2 and Z2 minus Z2 in the formula Z1 plus Z. So here Z1 plus Z2 and Z1 minus Z2 is there. Now what we will do, as here what is given, we will do that. Left hand side what is given? Modulus of Z1 plus Z2 square, modulus of Z1 minus Z2 square. So we will write as it is now. What is Z1? X plus IY. sorry, x plus z1 plus z2 we have done already. Z1 plus Z2 we have done already. What we have got? X1 plus Y1 plus I Y1 plus Y2. This one we have got already. Square, square. Plus modulus Z1 minus Z2 we have done already. X minus X2 plus I Y1 minus Y2 square. This is square. I have put as it is square. I have done nothing. Just I have put the value. Now let us come here. It is done here. So still let me show you. I will go to a formula now. Modulus of this one. Modulus of z is equal to square root of x square plus y square. Look here. Very carefully. Modulus of z is equal to square root of x square plus square. If modulus of z is square, then x square plus y square. That means squaring both sides. I hope you understand. This square will be as it is. Square and root cancel. X square plus y square. Modulus of z square is x square plus y square. We have done somewhere. I am not getting here. Modulus of z square is equal to x square plus y square. This one. Modulus of z square is equal to x square plus y square. This is the, let me show you again. Modulus of z is equal to square root of x square plus y square. This one already we have got in first formula. This one. Modulus of z is equal to x plus y square. OP means modulus. Modulus means square root of x square plus y square. Modulus will be written this way. So this one already we have got in first formula. Okay. I think this one, no? Yes. Modulus of this. I will show you again. Modulus of z is equal to square root of x square plus y square. If both sides z is whole square, then x square plus y square whole square, or modulus of z square is equal to x square plus y square. Square root cancel. So this one I hope you understand. Now same thing we will do here. Look here. Modulus of z1 plus z2 square. Let me show you again. Modulus of z square is equal to x square plus y square. Modulus of z. This is z. This is x. This is y. X plus I y. X plus I y. Modulus of x plus I y. Modulus of z means what? Z means x plus I y square. Z means what? X plus I y square square equals to what? X square plus y square. This is what I want to make you understand. This is x, this is y. Modulus of x plus I y square will be x square plus y square. This is x. X1 plus y1. This is x square. Y square, y1 plus y2 square. Same thing here also. Here also square is there. X plus I y modulus square is there. So x square plus y square. This is x. This is y. So plus x1 minus x2 whole square plus y1 minus y2 whole square. I hope you understand. Now there is nothing to, just we will apply a plus b whole square formula, a minus b whole square formula. A plus b whole square formula. X1 square, y1 square, 2x1, y1. This one, y1 square, y2 square, 2y1, y2. This one, x1 square plus y1 square minus 2x1, y1. This one, y1 square plus y2 square minus 2y1, y2. So plus 2x1, y1 minus 2xy, y1 plus 2y1, y2 minus 2y1, y2. x1 square plus x1 square. x1 square plus x1 square, y1, y1, y2, x1, x2. This one should be x, y1, y2. Z plus, here I have written something wrong, x1 plus x2. x1 plus x2, y1 plus y2. x1 minus x2, y1 minus x2. So here it is written x1 plus x2, y1 plus y2. x1 minus x2. So x1 plus x2. It is there already. x1, y1 plus y2. x1 plus x2, y1 plus y2. x1, x2, x2, y2, y1, y1, y2, y2. So everything 2 times we have got. 2x1 square plus 2x2 square plus 2y1 square plus 2y2 square. We have got like this. Isn't it? Now 2x1, this one and this one, okay? x1 square plus y1 square, 2x2 square plus y2 square. So x1, y1, 1, 1 taken together, 2, 2 taken together. After that, now what is to show? What is to show? Twice z1 modulus of z1 square plus modulus of z2 square. Modulus of z1 square, already we have already explained. Modulus of z square is equal to x square plus y square. Modulus of z1 square. Modulus of z1 square means what we have to get? x1 square plus y1 square. If z is x, z means what? X plus iy. Z means x plus iy. So modulus of z square is x square plus y square. If z is a plus ib, then we could have got a square plus b square. If z is x1 plus iy1, then we will get x1 square plus y1 square. x1 square plus y1 square. So 2, what we will write here? x1 square plus y1 square. X square plus y square is z. A square plus b square also z. Everything z only. What is z? X plus iy. If it is z a plus ib, a square plus b square. If z is x1 plus iy1, then x1 square plus y1 square. x1 square plus y1 square means what? What is x1 y1? x1 y1 is z1. So z1 square. So this is z2 square. 2 can be taken common. So it is got like this. Example 1. Prove that number 1 modulus of z is equal to 0 if and only if z equals to 0. Now we have taken z equals to a plus ib. Then we have to show, and if z equals to a plus ib, together you can have z equals to a square plus modulus of z equals to a square plus b square. Now suppose if modulus of z equals to 0, suppose you can write this one. Now if z equals to 0, modulus of z equals to 0, that means here 0. Modulus of z equals to 0. Modulus of z equal to 0. So in place of modulus of z, what you will write? A square plus b square. That means what? Square root of a square plus b square equals to 0. Or if we do squaring both sides, then a square plus b square equals to a square plus b square equals to 0. If a square plus b square means what? What is a square plus b square? So we themselves could here what is then prove that if modulus of z equals to 0 if and only if z equals to 0. That means vice versa. If modulus of z equals to 0, prove that z equals to 0. If z equals to 0, then prove that modulus of z equals to 0. So if modulus of z equals to 0, then a square plus b square equals to 0 we have got. Now look here. If any two numbers, if we add, we will never get 0. If any two positive number, we add, then we will get never 0. Written here. Since sum of two positive numbers cannot be 0, so sum of two numbers cannot be 0. So I hope you understand. Sum of two positive numbers cannot be 0. So if cannot be 0, then both must be 0. Two positive number. So minus 1 minus plus 1, 0. Yes. Minus 2 plus 2. Yes, 0. But one is negative, one is positive. But two positive numbers simply cannot be 0. If it is 0, then there is only one possibility, both must be 0. A square must be 0, b square also must be 0. That means what? If a square is 0, a equals to 0, b also equals to 0. So a equals to 0, b equals to 0. Okay, that means a plus ib equals to 0 plus I dot 0. A is 0, b also 0. 0 plus I dot 0. That means equals to 0. A plus ib is equal to 0. A plus, what is a plus ib? Z. Z equals to 0. We have proved. What is a plus ib? Z equals to 0. Finished. Then it is conversely same thing. Number 2. What was number 2? Number 2, modulus of z is greater than equal to 0. Modulus of z is greater than equal to 0. This one you have to show now. If already we have got a is 0 and b is also 0. If a and b both are zeros, then z equals also 0. Then z also equals to 0. I hope you understand. Z equals to a plus ib. A is 0. B also 0, then 0 only now. So if a and b both are 0, z equals to 0. So modulus of z also equals to 0. But if either a is not equal to 0 or b is not equal, or both a is not equal to 0, b is not equal to 0, then z will be. Look here, this is very important line. Either a is not equal to 0, b is not equal to 0, a not equal to 0, b not equal to 0, both. This is either or, this is both. Then modulus of z is equal to a square, square root of a square plus b square is not equal to 0. If a and b are both 0, then z equals to 0. So modulus of z also equals to 0. But if either a equals to 0 or b equals to 0, or both a not equal to 0, b not equal, then z is not equal to 0. But also what we have to do? Modulus of z is greater than equal to 0. Equal to 0 and greater than equal. So also in this case, square root of a square plus b square is a positive number. Look here, you forget about this. Square root of a square plus b square. Square root of anything, we will get always here in what is called complex number, always positive number. Positive number means what? 0 or greater than 0. So modulus of z is always greater than 0. Modulus of z means what? Square root of a square plus b square. Modulus of a square plus b square is always greater than equal to 0. Example number 2. This is very important now. Look here. Plot the numbers minus 3 plus 3i, 1 plus 2i, 5 plus I, 1, 2, 3. So this one ordered pair. Minus 3, 3, 1, 2 and 5, 1. So minus 3, 3. Then on an argon pair show that these are collinear. So minus 3, 3. Let us put minus 3. 1, 2, 3. Up 3. 1, 2, 3. This is minus 3, 3. Then 1, 2. 1, 1, 2. This is 1, 2. Both are positive in first quadrant. Next 5, 1. 1, 2, 3, 4, 5. Then 1. This is 5, 1. And so already put the numbers that show that these are collinear. Collinear, what is the meaning of collinear? Collinear means it's a straight line. A, B, C, non-collinear. A, B, C, D. 4 points are there. If we join all the points by a ruler or scale, then if the line segment gone through all the points, then A, B, C, D are called collinear. But A, B, C, we have got two different lines. This is not one straight line. AB is different straight line, BC is different line segment. So these A, B, C are not called collinear. They are non-collinear. But when we join these 3 points with the help of scale, then all the line segment will pass through. Line segment will pass through these 3 points. So which is called collinear. So it is done here. So I have shown here separately. You will do yourself and you will join these points with the help of a scale or ruler. So number 1 is finished. By joining 3 points, if the line segment doesn't pass through the points, then you cannot say these 3 points are collinear. So it will surely pass through the points. Number 2, find the conjugate of the above numbers. Conjugate minus 3 plus 3i. So we will write now. We will write here minus 3 plus 3y. Now we will write 3 minus 3i conjugate. 1 plus 2i. Sorry, minus 3 plus 3i. Minus 3 minus 3i. Then 1 plus 2i. 1 minus 2i. Then 5 plus I. 5 minus I conjugate. So what is the order pair? Minus 3 minus 3. 1 minus 2. This one 5 minus 1. Remember that. Minus I means minus I 1. So now we will plot the points. Minus 3 minus 3. Minus 3 minus 3. See, this is the quadrant in which both will be minus. Minus 3 minus 3. 1, 2, 3. Again 1, 2, 3. This is minus 3 minus 3. Next 1 minus 2. This is 0. 1 minus 2. So y is down. 1, 2. This is 1 minus 2. Then 5 minus 1. 1, 2, 3, 4, 5 minus 1. This is 5 minus 1. If you join these points by scale, then the line segment will pass through the points. So that is why it can be shown as collinear. These 3 points are also collinear. So 3 complex numbers are given and another 3 complex numbers are given which are conjugate of these complex numbers. So whether complex numbers, all the points are plotted on the graph paper argon plane. We have seen the line segment is passing through all the 3 points. So these 3 points are called collinear. And the line segment joining the points of what is called conjugate complex number also collinear. So by plotting you can prove yourself. You can take any other example also. Find the conjugate of the above numbers. Can you say that these are collinear? So it is done already. Number 2, 3. This one should be 3. The conjugate of PQR respectively PQR which x minus 3. This one is done already. So you don't have to see anything. This one no need. Already done. This example number 3 is important. Example number 3 is important. Okay. Given a plus ib and c plus id are two complex number. A plus ib and two complex number. A plus ib and c plus id two complex numbers. And demonstrate the following on argon plus sum of these numbers. Sum of these numbers means a plus ib plus c plus id. This one. Sum of these numbers. These two complex numbers, after addition we have to show in the on the argon diagram. So suppose so what is called, this one is taken as P, A comma B. This one is taken Q, I think, yes, Q, C comma D. Here A, B, C, D. So we will take 2 points anywhere. Anywhere we will take. Here, this is P, A comma B, and Q. This should be a little bigger. Q, C comma P. This is O. This is origin. So let us join OP and OQ. OP and OQ joined. Now, with the help of OP and OQ, we will draw a parallelogram. This is, I hope it is looking like parallelogram. You are okay. This is, so with OP and OQ we have got from the complex numbers, because P and Q we have got with us, OP we have joined, OQ we have joined. After that, this and this parallel drawn, this and this line segment parallel drawn, so that it becomes a parallelogram. Parallelogram. After that, OP, the diagonal divide each other. Okay. Diagonals. This is diagonal. This is diagonal. This is M. Okay. Now, I will draw this parallelogram separately here. Then you will understand. O, P, Q, R. This diagonal I have drawn. And this diagonal also I have drawn. As we know, first of all, property of parallelogram. According to property of parallelogram, we know that diagonals bisect each other. That means QP and OR bisect each other at point M. That means QM is equal to PM, OM is equal to MR. It means M is the midpoint of QP. Q we know C comma D, P we know A comma B. So M will be A plus C by 2 comma b plus d by 2. X middle point, so by 2. This point and this point, if we add whatever we get, we will have to divide by 2 because midpoint half. Again y and y, if we add whatever we get, we have to divide by 2 because half middle point. So m means midpoint of diagonals. If m is the midpoint of PQ, m is also midpoint of OR. So m is not only for PQ, m is also for OR. So for OR, but we consider the coordinates of R be xy, then on the basis of coordinates of O and R, we can find the coordinates of midpoint this way. Okay. R we have not written there. R is taken as x comma y. P is AB, we have taken from complex number. Q is CD, we have taken from complex number. R we have taken let xy because we don't know. But M we have come to know. This one we have come to know just now. Comma. Here also this is a point. Yes, comma. Maybe whatever number. Okay. So we have taken R. So for look here. This origin O means 0, 0. That you know, I think. R means what? X, y. To find out the midpoint of PQ, we have done A plus C by 2, B plus D by 2. To find out the midpoint of M for OR, 0 plus X by 2, 0 plus X by 2, 0 plus Y by 2, or X by 2, Y by 2. So this is the midpoint. This is M only. M is the midpoint of OR. M is also midpoint of PQ. But point is same. Here suppose the coordinate of M is suppose 5, 3. Suppose I am saying, if M is the midpoint for PQ, coordinate is 5, 3, point is 5, 3, then for OR it cannot be changed. So A plus C by 2 and X by 2 equal. B plus D by 2 and Y by 2 equal. Because 5, 3 will be the midpoint for both the coordinates. It cannot be, this point cannot be changed. This point, how much? 1, 2, 3, 4, 5, 6. 1, 2, 3. This is minus 6, minus 3. If we draw a line like this, all are crossing this point. All are passing through this point. It does not mean that this point will change. This point will be as it is. So A plus C by 2 equals to, this one written here, there is no space, so I have shown here. X by 2 equals to A plus C by 2, and Y by 2 equals to B plus D by 2. So 2 cancel. A plus C equals to X, B plus D equals to Y. A plus C equals to X, B plus D equals to Y. X plus IY. X plus IY equals to, X means what? A plus C, Y means B plus D, there is I, so we can write like this, X, Y. A plus C plus I, B plus D, which represents by R in the organ plane. So X and Y, X, Y. So in place of R, X, Y, we can write here A plus C, B plus D. X means A plus C, Y means B plus D. So this is the coordinate. So what we have shown here? Sum of these numbers means what? A plus C and B plus D. A plus IB plus C plus ID. If we write this way, A plus C plus I, B plus D. If we add these two complex number, we get A plus C plus I, B plus D. So this is X, this is Y. This one and this one we have got there. In the organ plane only we have got there. So it shows that some of these numbers can be demonstrated on the Argon plane. So difference of these numbers. Difference of these numbers also we can show in here. This is difference. So previous sum what we have got? A plus C, B plus D. Now we will get C minus A, D minus B. Previous one what we have got? Previous one we have got A plus C plus I, B plus D, which we have shown in R. Now we will have to show this one, difference. Difference of this one, minus. This one we have to show here. So here actually what we have to do, it is previous part is same. Previous part is same. We will take here P, then we will take Q. Here P means A comma B and Q means C comma D, like previous one. Then OP join and PQ join. OP and PQ join. From P perpendicular is drawn. From P perpendicular is drawn. Then we have to first of all make it a parallelogram. OPQR. OPQR. This one is X comma Y, like previous one. X comma Y means this one X, this one Y. We have to get in that X C minus A, in that Y D minus B. We have to get like previous sum only. In previous sum we have got A plus C and B plus C. Now we have to get X. Then only it will be proved. Okay. Now perpendicular drawn. This one LMN. Okay. This one is S. From P to S also perpendicular drawn. One perpendicular, two perpendicular, third perpendicular, fourth perpendicular. This is drawn. Now triangle ORL and triangle PQS. We have to prove these two triangle congruent. ORL. This triangle and PQS. These two triangle we have to prove congruent. To prove these two triangle congruent, we need three conditions as we know already. So for that, OL equals to, we see that OL equals to PS. Now we will, these two triangle, if we can prove congruent, three conditions are required. So we see how conditions, this one and this one equal. This is a parallelogram, opposite sides of parallelogram as we have got. Now we know that, now look here, this angle and this angle, if they are equal, then we can write A, but not sure. We have to show here. Triangle is like this triangle, OLR, this angle, and QPS, this angle. If we can say, then we can go to A. but we are not sure they are equal or not. But how can it be equal? We will show you. Look here. This is a right angle triangle. This is also a right angle triangle. This is 90 degree. This is also 90 degree. This is hypotenuse. This is hypotenuse. Two right angle triangle we have got. This is hypotenuse equal to equal. OL equals to PS equals to MN. OL and PS equal. OL and PS equal. Where? This here to here distance equal. So OL equals to PS equals to PS and MN equals to MN equals to MN. P means A comma B, I think, no? P means A comma B. Q is written C comma D. It is not written till now. Okay. Now O to N, how much? C. I think you understand. Then O to N C. Then O to M, how much? O to M A. O to M A, because it's x-axis, so first one you have to take. O to N C. MN means ON minus OM. ON minus OM will be MN. ON we know C, OM we know A. So C minus A. We have got OL, C minus A. Then we will go to RL. RL is equal to QS, because this is RL. These two triangles are congruent. RL and QS. RL is equal to QS. QS. This one. QS means what? QS means QN. QN minus QS. Look again. QN minus QS. So SN, we need QS. Look here. QS. QS means QN minus SN. QN minus SN. QN how much? QN minus SN. SN means PM equal. SN means PM. QN, let us write how much. QN, Y. So D. PM, Y. For Y, B is there. So B. So RL we have got D minus B. Then OL we have got C minus A. So what is RL? X axis X C minus A, Y D minus B, X C minus A, Y D minus B. This is calculation of X axis. This is calculation of Y axis. So this is X, this is Y. This way. Please repeat. Please see what is written in the book. This is also very, very important. If 1 plus I into 1 plus 2I into 1 plus 3I dot 1 plus Ni is equal to A plus Bi, then show that 2, 5, 10 1 plus N square is equal to A square plus B square. It is very easy but important. Now, as thus like I will show you, let Z1, Z2, Z3, Zn equals to how much? Modulus of Z1 into Z2 into Z3 into dot 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 into Zn is equal to how much? Modulus of Z1 Z2 is equal to modulus of Z1 into modulus of Z2. This one is a property. So equals to, we can write modulus of Z1, modulus of Z2 into modulus of Z3, modulus of Zn. We can write this according to this property. This one already, please catch the picture. Please remember the picture. There is a formula. So now this one, note in solving this problem, it is generative property like this it is given. Okay. Now what is given actually? It is given that 1 plus I, 1 plus 2I, that means Z1, Z2, Z3, dot 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 Zn, it is given like this. So we will write in modulus now. 1 plus I, 1 plus 2I, 1 plus 3I, dot dot dot, 1 plus Ni, modulus. This is modulus written. Equals to A plus IB, no? IB. Let me write this here. Both side putting modulus. This is given, no? In given both side, we will like both side doing squaring. When we do squaring, then we can do both. We have to do both side. So here one side we cannot put modulus. We have to put modulus both side. Now this one again I will show you. Z1 Z2 is equal to this one, if you remember. So same thing here. Modulus of 1 plus I, modulus of 1 plus 2I, modulus of 1 plus 3I, dot dot dot, modulus of 1 plus Ni is equal to modulus of, let us keep for timing like this. Okay, what to show? A square plus B square. Okay, then we will get modulus of A plus IB is square root of A square plus B. Then we can write this one. Now this one, modulus of A plus IB, square root of A square plus B square, 1 square plus 1 square, into modulus of 1 plus 2I, square root of 1 square plus 2 square, again modulus of 1 plus 3I, square root of 1 square plus 3 square. I hope you remember. Modulus of Z is equal to modulus of X plus IY. Modulus of X plus IY is equal to square root of X square plus Y square. This is a formula. So modulus of 1 plus I, X is 1, Y is 1. So X square plus Y square. Dot dot dot, modulus of 1 plus N square equals to square root of A square plus B square. Sorry, I have told here modulus, not modulus. Square root 1 square plus N square. Now 1 square plus 1 square is root 2. Again root 1 square is 1, 2 square is 4, 4 plus 1 5, 3 square is 9, 9 plus 1 10, dot dot dot, let it be 1 plus N square equals to square root of A square plus B square. Now square root of 2, square root of 5, square root of 10, like this. Look here. If it is square root of 3 into square root of 5, we can write square root of 15. So same way, here we can write square root all together. Square root 2 into 5 into 10. 10 is there or not? 2, 5, 10. Yes. So we have to see what is there in left hand side also. So 2, 5, 10, 2, 5, 10, another thing is not required. Dot 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 1 plus N square, 1 plus N square equals to square root of A square plus B square. Root both sides can get cancelled. So 2 dot 5 dot 10 dot 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 1 plus N square equals to A square plus B square. Hence proved. Very simple but important. So in next video, I will do all the sums of exercise 2.3. So till this much, all the examples and graph, everything I explained. I hope you understand. If there is any issues, please write in the comment box. If I see that if there is any issue regarding this graphical representation of complex number. I will explain it again if it is required. If you want, I will explain it again. Otherwise, in next video, I will start exercise 2.3. So till then, have a good day.